Hi Mathsy people, Mr. Hannah back with our probability series. This video is all about Karnaugh Maps. These are just probability tables, another way to represent a Venn diagram. So it's the same information in a Venn diagram, represented a new way. And some people really love these because they make the maths part of it a bit easier to understand. Because you don't need to use the formal addition law. That's the addition law that says that the union of two events, probability of that is the probability of event A plus the probability of event B, subtract the probability of A intersecting with B. So you don't so much need to use this for this occasion. Okay, so let's suppose that a survey was done for 100 people. 100 people were asked if they have, in the last 24 hours, have they eaten an apple or a banana or both an apple and a banana? So, apple only, or banana only, only, or both. And let's say that 50 people said they'd only eaten an apple, and 20 people said they'd only eaten a banana, and 15 people said that they had eaten both an apple and a banana. So let's write some probabilities down. Let's say that event A is apple. They've eaten an apple. Event B is banana. So that would mean that for both, that is A and B. Okay, so let's put this information into a Venn diagram. Okay, apple and banana. Now, 15 out of 100 people have had both. So that would be, let's just quickly work these into percentages. So if this 50 out of 100, that's going to be a probability of 0.5. 20 out of 100, that would be a 0.2. And 15, that would be a 0.15. So both is 0.15, so that's going here, 0.15. Now, this is apple only. So that means this goes into this zone here, because that's apple only. It doesn't mean apple at all, it just means apple only. So that's a 0.5 here. And banana only, 0.2, that goes here. Now, if we want to find out what goes on the outside, that's 0.5 plus 0.15 plus 0.2 is 0.85. So to find out what's going on this outside bit, remember this is like the probability of a union with B. So to find out the probability of not the union, that's 1 minus 0.85, which gives 0.15. So out here, that's a 0.15 out there. Remembering this is our sample space. Okay. So now, let's just write some better symbols down for these things. So this is 0.5, apple only. That is the probability of an apple and not a banana. This bit here is the probability of a banana and not an apple. So not an apple and a banana. 0.2. We can also say the probability of just an apple, that's 0.5 plus 0.15, that's 0.65. The probability of a banana at all, 0.2 plus 0.15, 0.35. So here's lots of probabilities we can get from this Venn diagram, this very handy Venn diagram. We can basically find all the different probabilities that anyone could possibly ask for us just by finding the different zones. Okay, so now let's turn our attention to this new thing called the Karnaugh Map. Okay, now here it basically is. We have our different events. So let's say event A, someone eats an apple, or possibly the complement of that, someone doesn't eat an apple. And of course here we have someone's eating a banana, or someone's not eating a banana. And these will basically form our table. Okay, so here we go, put in a table. Alright. So what's going on with this table is this value here is the probability of event A. And this one must be the probability of not event A. Yo. Here we go, the probability of eating a banana, probability of not eating a banana. And here this is the probability. Oh, let's go through these center things first. This is the probability of having an apple and having a banana, because it's the apple and banana. Here this is the probability of not having an apple and having a banana. Here this is the probability of an apple and not a banana. Apple and not a banana. And here's the probability of not an apple and also not a banana. Okay, this one here is basically everything. Okay, it's the probability of a banana and not a banana, which must be 1, or the probability of an apple and not an apple. So in other words, this is a probability of the whole sample space. So this one here is always going to be 1. So let's draw the table again, but with actual values this time. Okay, so the first thing we do, we put a 1 there, because we know that everything together has a probability of 1. Alright, next up, let's put in the information we were told at the very start, which is that an apple only, in other words, an apple and not a banana, is 0.5. So that's an apple and not a banana, 0.5. We also know that a banana only, so banana but not apple, is 0.2. So that is banana, not apple. Last piece of information, both. So that banana and apple, apple and banana, 0.15. Apple and banana, 0.15. Now we can fill in the rest of this table. So let's see, 0.15 plus 0.2, going across, gives us the probability of a banana. So that would be 0.35. Going down, add them together, we've got a 0.65. Okay, now this spot here, we need something to add to give 1. So that's going to have to be a 0.65 there. So probability of not getting a banana, 0.65. And here, something plus 0.65 gives 1. So that has to be a 0.35. So probability of not having a banana, 0.35. And in the centerpiece here, 0.5 plus something is 0.65, so that has to be a 0.15, which also makes sense going down. So we've filled it in, we've found all the possible probabilities we could ever want. And now we're ready to answer lots of questions. Now, before we do that, let's just compare between this table and our Venn diagram method, and we'll find that they're the same. So here's 0.5 for apple and not a banana is the same. Oops, apple, not a banana, it's the same. This one here, apple and a banana, it's the same there, apple and a banana. Now here we have banana and not apple. Banana, not apple, 0.2 is the same. Now let's look over here. Probability of a banana, 0.35. Probability of a banana, 0.35, that's the same. probability of an apple, 0.65. That is the same. Okay, so that's good. And what else have we calculated? I don't think we've calculated anything else, but to find the other ones, let's use our Venn diagram. So probability of not an apple and not a banana. Oh, we've got that one here too. Here it is, 0.15 for not an apple or banana. So we do have that one too. Now let's find the probability of not having an apple. So that'll be everything except for stuff in A. So it's all this stuff. In other words, it's this 0.15 and also this 0.2. So it's going to be 0.35. And yep, 0.35, good. And our probability of not having a banana, it's the same thing, but everything except that circle. So it's 0.5 plus 0.15, and that's 0.65. So yes, we had that one too. So hopefully you can see that these are equivalent to each other. The Venn diagram approach or the Karnaugh map, they're just a different way of basically doing the same thing. Okay, the Venn diagram, in my opinion, the Venn diagram is more visual. Venn diagram is visual, and the Karnaugh map, so that's up that way, and this Karnaugh map, Karnaugh map is a bit more mathematical, I think. It's a bit more mathematical. So whichever approach you like better, that's the one you can use. So there you go. So remember, to get these bottom ones, you add those up, and you can add sideways up to get those as well. So there you go. That's all there is to it for the Karnaugh maps. So good luck with those.